All right, today we are going to be looking at some even and odd properties and some identities and different things like that. Okay, so here's what you need to know. First of all, I want you to hit pause and I want you to find the values of these angles right here. So I want you to find sine at positive 30, then sine at negative 30, sine at positive 60, then sine at negative 60. So hit pause and do that. And you can check your answers by doing this. This is what should happen when you find sine at positive 30, sine at negative 30, sine at 60, sine at negative 60. You should notice a pattern. Notice at positive 30 it's 1/2, at negative 30 it's negative 1/2. They're all opposite signs. That's because sine is what is called an odd function, and we'll talk about that in just a minute. Okay? Now I want you to go over here and I want you to find these values. Cosine at 30 and negative 30. Cosine at 30, and you can hit pause and do this and then check your answers. Okay? Here what I want you to notice is that they have the exact same value. Sine at cosine at positive 30 is the same as cosine at negative 30. That's because cosine is an even function. So it doesn't matter whether I'm finding it at positive 30 or negative 30, it will have the same answer. Okay? So you have this on your note card, and basically what that's saying is this. If theta was 30 degrees, for cosine and secant, cosine at positive 30 and cosine at negative 30 will have the same answer. So you don't really need this negative right here because the negative angle will have the same value as the positive angle. Okay? So on an even function, which are cosine and secant, you can take this negative and you can drop it. Okay? For an odd function, which is the other four trig functions, sine, cosecant, tangent, and cotangent, they will have sine at positive 30 will have the opposite answer as sine at negative 30. So what you can do is you can take this negative and you can pull it out in front, and you can find the positive angle and switch the sign on it, and that tells you that it's an odd function. Okay, so I know you can go, we're going to do this on our unit circle, and I know that you can find these by going to the negative angle. So like I know you could go to negative 45 degrees and find sine. I know that that's one way to do it, but you're going to need to use even and odds later. So I want you to practice this using the even and odd properties today. Okay, so 45 degrees you're going to go to. What I want you to look at today is sine an even function or an odd function? And it is on your master formula sheet. It does tell you which functions are even and odd, so hopefully you've got that there. Sine happens to be an odd function, and on odd functions you're going to take this negative and you're going to put it out in front. So this will be the same thing as negative times the negative of sine at positive 45 degrees. Okay? So then you're going to go to your unit circle to 45 degrees. 45 degrees clearly is right here. Your sine is your up-down value when you think of your triangle. My radius is 1 still, and so my sine value there will be root 2 over 2. And then I need this negative out in front, and so I need to put a negative there. Okay? Next one, cosine happens to be an even function. Cosine is an even function, and so this negative right here can just be dropped, and it will be the same thing as cosine at positive pi. Okay, so I go to my unit circle again. Positive pi is over here. Cosine is your left-right value, or your x value, and so cosine will be negative 1. In the next one, cotangent is an odd function, and again, odd functions, you'll take the negative, you'll bring it out in front. So this becomes negative of cotangent 3 pi over 2. All right, so you're going to go to cotangent. You're going to go to 3 pi over 2 down here. Cotangent is your x over your y, or your 0 over your negative 1, and so that just becomes 0. Whoops, wrong way. And negative of 0 is still 0. Okay? Tangent at negative 37 pi over 4. Again, tangent is an odd function, so you'll take the negative and you'll bring it out in front. So I will have negative tangent of positive 37 pi over 4. For some people here, the hardest part is to figure out where you are on your unit circle. And 37 pi over 4 is the same as 9 and 1/4 pi. So you need to figure out where that is. 9 and 1/4 pi, if you go to your handy dandy unit circle, there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, and an extra 1/4 of a pi puts you right here. So here's where 37 pi over 4 is. Tangent is your y over your x, or your opposite over your adjacent. So your opposite would be right here. Your y value is negative root 2 over 2. Your x value is right here, or your left-right value is negative root 2 over 2. So if you have negative root 2 over 2 over negative root 2 over 2, you have positive 1. Okay? And so when you go back here, you will have negative of 1, which is just clearly negative 1. Okay? And one more down here. Sine at negative 13 pi over 4. Sine is an odd function again, so I'm going to go over here. I'm going to pull that out, and it'll be the opposite of sine at 13 pi over 4. Plus, and then cosine is an even function, so this negative right here can just be dropped. I don't need it, and it will be the same as cosine at 9 pi over 4. All right, so now I'm going to go over here. I'm going to first of all figure out where 13 pi over 4 is. I'm going to erase all this so it's not so mumble-jumbled in here. 13 pi over 4. So 13 pi over 4 is 4 and 1/4 pi. So if you think about that, 4 and 1, no, I'm sorry, it's 3 and 1/4 pi. 13 over 4 is 3 and 1/4 pi. So 3 and 1/4 pi will go 1, 2, 3, and an extra 1/4 of a pi puts you right here. I'm asking you to find your sine value there. Your sine value is your up-down value, okay? And so at that spot, it will be negative root 2 over 2. And so I go down here, and I have the negative of negative root 2 over 2, which obviously becomes positive root 2 over 2. Okay? And then to that, I need to add cosine at 9 pi over 4. So I'm going to go back over here. 9 pi over 4 is 2 and 1/4 pi. So if I go around, there's 1 pi, 2 pi, and an extra 1/4 of a pi puts me right here. Okay, and I'm asking you to find cosine at that spot. Cosine is your your adjacent over your hypotenuse, or your left-right value, or your x value, and that will be square root of 2 over 2. So cosine there will be square root of 2 over 2. Now, I want you to think about this. You need to simplify. When you add fractions, you need common denominators, which I have, which is fabulous. And remember, you don't add the denominators. So the denominators don't become 4 because I don't add them. So my common denominator is 2. And then what you need to think about is this. I have 1 root 2 right here, and I have 1 root 2 right there. And when I add 1 root 2 plus 1 root 2, I get 2 root 2. And then these 2's will cancel, and I will get root 2. Okay, so that is that. Then we are going to move on to these positives and negatives by quadrant business here. Up here in the corners of your unit circle, you will see these, okay? This tells you which trig functions are positive and negative in whatever quadrant you are in, okay? So you can see that cosine is positive in quadrant 3 down here. This is quadrant 3. And sine, tangent, cosecant, and cotangent are all negative, okay? So you can kind of fill in that little circle if you want. And I think I have this on your note sheet maybe, that I have this, that sine and cosecant have the same odd positive and negative properties. So they go like this. And cosine and secant, and you can get these right from just looking at those little things on your unit circle there that I have for you. Cosine and secant go like this. And tangent and cotangent go like this. Okay? All right, so you need to figure out what quadrant this angle it lies in. So I have some angle. What I know is that cosine is greater than or equal to 0. And what I'm amazed by is when I say, tell me what this means in one word. Cosine is, in one word, people have a hard time filling that in. If it's greater than 0, it means that cosine is positive. That's what that means. It means that cosine is positive. That's what this is telling you. Okay, so you need to find the one quadrant where cosine is positive, and if it's less than 0, that means that tangent is negative. Okay? And there's one quadrant where both of those things happen, where cosine is positive and tangent is negative. So right here, cosine is positive, that's great, but tangent is not negative. Over here, cosine is negative, so that's not going to work. If you go down here, cosine is positive, tangent is negative right there. So that happens in quadrant 3. And just so you remember, it goes 1, 2, 3, 4. And it's not quadrant 3, it's quadrant 4. Sorry, did I say 3? I think I did. Anyways, cosine is positive, tangent is negative in quadrant 4. Okay, and the next one's asking you to figure out where is sine negative. So sine is negative. And right here, cotangent is negative. So sine and cotangent both have to be negative. So they're both on the negative list. Sine and cotangent, again, down here in quadrant 4. Sine and cotangent are both negative in quadrant 4. Okay? And then, lastly, we're going to look at some basic identities. Here are 3 basic identities that are that you need to know in trig. This is a huge one that will carry you throughout trig, throughout calc, throughout whatever. You absolutely have to know that one. That sine squared plus cosine squared is 1. Just so you know where that kind of came from, sine squared is like your y squared. Whoops. Sine, you know, is like your y value. So what this really is it's saying y squared plus x squared. And then as long as you're on your unit circle, your radius is 1, so that's 1 squared, and that's kind of where that came from, okay? And I could tell you how all the others were developed from this one right here. I'm not going to take the time to do that. But if you look at your master formula sheet, all of the identities are listed there. And what I've done on your master formula sheet, too, is I've switched them so that I've manipulated them and solved them for different kinds of equations, okay? So you can see all the different versions there. All right, so here you guys, you need to find the exact values, and in this case I'm giving you 35 degrees, and 35 degrees is not one of the special angles you have marked on your unit circle, so you need to have a different strategy for it, okay? Just to give you a hint, there's a square in this equation, and that square is huge because most of the time when you have a square in your equation, it's going to be a hint to you that you're going to need to use one of these identities here. Okay? On your master formula sheet, you have an identity that looks like this. Sine squared at theta plus cosine squared at theta is, and here's the deal. In this case, it doesn't matter what theta is, but theta has to be the same angle both places. It can't be 35 one place and 85 the next. That's not going to work. As long as theta is the same both places, sine squared plus theta plus cosine squared theta is every single time going to be 1. Okay? Every single time it's going to be that. Okay? Here's another one. Again, you have squares in your equation. Big hint that you're going to need to use your identities. You have an identity on your note card that looks like this. Cosecant squared minus cotangent squared, guess what, is 1. Okay, in this case, your theta is 42 degrees. So cosecant squared at 42 minus cotangent squared at 42, guess what, is 1. Okay, now I don't have squares in my equations, so now I need to use a little bit something different. I can't use my identities because they're not squared. I need to use a different property. On your master formula sheet, where it talks about the trig properties, Um, you need to know that these can be manipulated with reciprocals, basically. Secant and cosine are reciprocals of each other. So I could rewrite cosine as 1 over secant. I could also rewrite secant as 1 over cosine. It doesn't matter which way you do it. It makes no difference. But I'm going to rewrite secant using its reciprocal. Okay, secant and cosine are reciprocals of each other. So if you leave it like this, then what happens is those will cancel. And again, I'm going to get 1. I can't do this on my unit circle because I don't have coordinates at 67 degrees. And when I tell you I want exact values, that means you can't use your calculator. You have to use other properties, okay? So know that. All right. Here I've got another one. Again, very similarly, cosecant is the reciprocal to sine. So if I use my reciprocal properties, cosecant I can rewrite as 1 at sine over 57. And if I rewrite it like that, you can see that you have the same quantity that you're subtracting from the same quantity. Well, if you have 5 minus 5, you have 0. If you have 1 over sine at 57 minus 1 over sine at 57, you have 0. Okay? And that should do it. I think you might have one more on your note sheet. I'm not sure. But you might have this one. I'm going to do it just in case you do. Okay, I think it'll look like that. With tangent, you can write tangent as its reciprocal, which is 1 over cotangent. You can also write tangent as sine over cosine. So I am going to rewrite tangent as sine over cosine right here. And again, I'm getting all of those from my master formula sheet. And again, if I have the same quantity and I'm subtracting the same quantity from it, I will have, oops, not 0, or not 1, but 0. Okay? So that should do it for today.